Good day, and welcome to tonight's video, or today's video, which is we want to be able to use properties of logarithms. And we're going to go through the properties, and we'll have an example or two of each one. So, let's get started. And the first one is the log of a product. Now that would be something like the log of any base of, not a, because we used a for any base, x times y. Well, that's equal to the log of that base a of x plus the log of that base of y. Nice little example here would be something like if we had the log base 7 of 5x. Well, that becomes the log base 7 of 5 plus the log base 7 of x. Now another example could be something like the log of log base 2 of 14. Well, we could think of that as the log base 2 of 7 plus the log base 2 of 2. Right, and that's the log of a product. Now moving on, our second property would be the log of a quotient. In other words, we'd have the log of some base x divided by y. Well, division is kind of the opposite of multiplication, so if you're guessing and playing along at home, this becomes the log base a of x minus the log base a of y. Yes, we subtract. Nice little example here. Let's go log of 7 over 12. That becomes the log of 7 minus the log of 12. Another example might be the natural log of 2 over e. And that would give us the natural log of 2 minus the natural log of e. And there we go. Now, let's see. The third one. Let's call this log raised to a power. In other words, we'd have something like the log of some base a of x raised to the r power. Well, what we can do is take that exponent and move it out in front. That equals r times the log base a of x. Nice little example. Log base 4 of 4 to the 5th power would equal 5 times the log base 4 of 4. Or another example, natural log 7 to the x power equals x times the log times the natural log. Of 7. The next one we're going to get a 2 for. And these I'm just going to show you. I'm going natural log again. Alright, log any base, doesn't matter. If we take the log of a base a, that equals 1. Example, if I took the log base pi of pi, that equals 1. As long as the base and the argument are the same, it always equals 1. Now, to go along with that, log any base of 1 equals 0. Now, if you think about this, remember we said logarithms equal exponents. So a to the 0 equals 1. And that should be comforting. That's like up here too. Pi to the first power equals pi. These kind of make sense. Example down here, natural log of 1, yep, that equals 0. Okay. Good. That's the fourth one. Now the fifth property we have here is the log of an inverse. In other words, if I have the log any base 1 over x equals negative log that base of x. Now this one should kind of make sense from that second one and the fourth one, because we could think of this as the log base a of 1 minus the log base a of x. Well, we know that the log base a of 1 is 0. So it just becomes negative log base a of x. We'll give you a quick little example here. If I had the log of 1 over 4, I would have negative log of 4. Okay, nothing to it. Nothing to it at all. And let's take a look at the last one, number 6. Okay, this one is the change of base formula. Right, because on some of the older calculators you could not change the base. Some of the newer ones you can. But if I take the log any base of x, I can change it to whatever base I want, and usually I want a common log, in other words log base 10 of x over the log base 10 of a, common log. Now this works with natural logs as well. Okay. Nice little example here. If I had the log base 3 of 7, well, I could think of that as the natural log of 7 over the natural log of 3, and that equals 1.771. And I encourage you to try that out on your own. Try a couple different examples. Try this one with common log base 10. See if you get the same answer. I bet you do. Alright, well, that's it for tonight. You have fun. Thank you, and good night.